There's a profound shift in terms of the way that AI programming is starting to work. It's much less about the detail of the code than it used to be. It's much less about the solution. It's much more about specifying what we want to happen in sufficient detail so that we can verify that that's what we got.
Hey, hello, and welcome to Hangar DX. This is our podcast about developer productivity and developer experience. We talk about how engineering teams solve complex productivity challenges. I'm your host, Ankit Jain, co-founder of Aviator. At Aviator, we are building AI code verification platform that creates guardrails for reducing AI slop. So I'm obviously very excited today to bring our guest Farley with us. Everyone probably has heard of Dave Farley. Welcome and thank you for joining us, Dave. A quick introduction. He's one of the authors of Continuous Delivery, one of the most popular best-selling books, as well as an inventor of deployment pipeline, wrote book on modern software engineering as well. So, and runs a very popular YouTube channel as well. Dave, thank you for joining us. Maybe you can also do a quick introduction yourself for folks who are listening, and we'll get going from there.
Yeah, it's my pleasure, and thank you for inviting me onto your podcast. Yeah, so I'm, as you can probably tell if you can see me, if you're looking at a video of this, then I'm quite old, so I've been around for a long time. I spent the vast majority of my career hands-on writing code in development teams, usually at the slightly more complicated end of the spectrum. I spent the latter part of my career leading teams and, working in roles like head of software development, those kinds of roles. So I kind of cross over a little bit between being a hands-on developer and being the man, the pointy-haired boss. But hopefully not too boss-like, not too pointy-haired. I'm interested in the things that we can do to do a better job of software development. I think there's a lot of software development that's practiced poorly. And so these days, I run a very small family firm, a consultancy, that helps organizations to do a better job of software engineering. And I think that's important. So that's me, I suppose.
Amazing. Dave, you're probably one of the most experienced people in software engineering that we have on podcast. You've been through many different eras of software engineering, right? Talking about Agile manifestos, like Agile frameworks, then DevOps movement happened, and now there's like the AI movement happening. Maybe you can share a bit of your journey and how different or similar is the AI movement compared to the other ones?
Sure. So I started writing software professionally in the early 1980s. So writing relatively low level stuff, often as in assembler, and playing with, memory allocators to take advantage of extended memory in early generation PCs, which current generation programmers won't know anything about at all, and all that sort of stuff. And I had a lot of fun doing that kind of thing. During the course of that, I got interested in ways of thinking about the systems that I'm building. And I think that one of the things that's always characterized the way that I think about things is that I think that design and the way that we think about solving problems is more important than the tools that we use to implement those designs. So I've never really been a strong language person. I have my preferred languages to use, like lots of other people and so on, but I'm not a tools person, which is a weird thing to say because a lot of my work is associated with high levels of automation, which obviously needs tools, but I'm not dedicated to one particular set. I suppose that's what I'm trying to say. So I think in terms of the shapes and so on, I think that the most significant things that I could point to that happened in my time were, first of all, the introduction of object orientation, the move from procedural languages into object-oriented thinking. That was a light bulb moment for me. That was a big step in being able to solve more complex problems more easily. Then there was the arrival of the internet. I was a very early adopter of the internet. I used the internet before there was the web. a little bit, and I used the first web browser that I had access to in 1992, I think it was, which was fairly soon after Mosaic, the first web browser, was written. That was obviously a huge change to the way that, not necessarily a progress initially. There were some ways in which it was a step backwards. User interfaces went from being quite rich and quite powerful to being quite crude and quite crappy because they were based on HTTP. And then, things got better again. I was a very early adopter of Agile thinking and Agile practice, and was involved. I worked in a consultancy called ThoughtWorks in London. For a while, I would claim rather grandiosely that ThoughtWorks in London was probably the centre of Agile thinking at scale for a period of time. There were lots of people that did very innovative things, including some of the things I worked on, but BDD, mocking libraries, the adoption of extreme programming at larger scale, continuous delivery, all of those ideas are things that came straight out of ThoughtWorks. And things that kind of changed our industry in the way that we think about them, and many more I'm not going to bore you by mentioning them all. But there was a lot of stuff that came out of there. I was an early adopter because I was kind of very dissatisfied with what I saw of kind of corporate programming at the time, which was very, very ugly and very poor on the whole. There was a lot of failures around that time for projects. I worked for a while in a consultancy that was essentially a project rescue organisation. We'd go in and help people fix their basket case projects. And we'd say, you probably don't want to look at what we're doing because you won't like it, but we can fix it. And then we'd work quickly, iterate fast, get feedback, do all of those things that these days we talk about, and do that. And a lot of that experience was where my book, Continuous Delivery, kind of came from. It came out of learning how to do that kind of thing. I think that the change to so I suppose during that time as well there was the web hype, the kind of market crash of the overhyping of web applications and web companies in the late 90s, that kind of thing that went on, which is another analogue for maybe how some people see where we are now. I think that the change without really much shadow of a doubt, the change that we are seeing now is bigger than all of those put together. This is bigger than the internet, bigger than object orientation, bigger than the agile transformation, all of which were huge, which were significant, which were kind of radically changed the way that we thought about and undertook software development. I think AI is bigger. And I buy into the skepticism as well. It's a huge change and it's not good enough at the moment. And I think there are some really naive things that people talk about and think about in trying to apply AI to helping us build better software more quickly. And I think people are often looking in the wrong places for some of those wins. I think one of the profound things that we are learning, and this is quite recent learning, I think we've had evidence of this only probably within the last year, which is a long time in AI terms, but is recent in everything else. I think within the last year we've learned that there's a big difference between the people who are already doing a good job of software development and the people that weren't, and the impact of the impact of AI on their work. People who are already practicing techniques like continuous delivery and I would say modern software engineering find dramatic, remarkable changes in the rate at which they can produce better software. And the quality of the software, the scale of the software that they can build. That's because they've got good practices. That's because the natural way in which they think about working incrementally, getting feedback, learning and adapting to what they learn is inbuilt already. And so that's a natural fit for working in the, you might say, chaos of an AI development process. People that can't cope with that kind of stuff, that are thinking more traditionally, thinking in terms of big waterfalls and long-term plans and all of that kind of stuff and big changes, hiding their work on feature branches and building weeks or months long features in isolation from everybody else, I think they just build worse software faster. And that's not good. That's just digging a hole. So I think there's a lot of change going on, and I also think that none of us know where this is going to end or how it's going to land, or even what the best things to do are. But I think we can see what some of the bad things to do are, and that's where we're at the moment.
Amazing. So, given that you are also big supporter of like the AI coding, or at least like how this, the evolution of software engineering is happening at this point, what does your setup look like? Maybe we start from there.
I confess I don't build as much software as I used to these days. So a lot of my work is advising other people on how to build software rather than doing it myself. So I have to confess that, some of this knowledge is less directly practical, I suppose, in the sense of me building real-world production systems. I do write code quite a lot, though. And these days with AI, I write quite a lot of code, but faster. So I'm bouncing around because I want to try out the different ways of thinking. So the different ways of working. So I've got the Gemini system installed. I'm primarily using Claude, though, for most those. But I've also been playing longer term with ChatGPT and those suites of tools. I tend to use them for different things now, and Claude is my go-to system for actually writing code, because it's just nicer. It just seems to work better. You still can't trust it. It's still not going to do the right things all of the time unless you really add a lot of constraints. One of the things early on that struck me was that there's a big problem with AI coding, kind of fundamental in principle. And I divide that up into three things, really. So the first thing is, if you think about programming languages and the history of programming languages, they are tools that were designed to help us think. They're not really for anything else. So yes, they allow us to express ideas concretely that a computer can execute, but fundamentally they're the shape they are because that helps us to think. It helps us to compartmentalize problems, decompose them into pieces that we can fit in our heads and reason about. And fundamentally, that's a good starting point. So a natural language, a human language, is not as good as a programming language as a tool to help us think in that way. It's not precise enough. It's too vague. It's too open to interpretation. The next problem is that these are tools that are, and this is a big problem, a programming language is a deterministic thing. If I write a program and I give it exactly the same input, get it in the right same state, give it the same inputs, I'm going to get the same result out. That's not true if I'm talking to an AI. I'm going to get different responses. I can give it exactly the same prompts or inputs, and it can do something different. And I know that there are ways in which I can try and lock down the AI to be less variable, but it's fundamentally part of how an AI works that you kind of want that variety as well. And so as a tool, that's a big deal as well. And the last idea is we need to also be able to tell that what it's doing, what we told it to. If the determinism in a programming language, it means that if we write the program, we know that we've got what the program says we've got. If we prompt an AI to do something for us, we don't know that it did it. It will cheat. It will lie to us a little bit. It will say that tests passed when they didn't. It will do all of these sorts of things. And so we've got to find ways to cure all three of those problems. And as I thought about this in my own programming and how I could do, it seemed natural to me that the obvious solution that fixed all of these problems to some degree is test-driven development. In particular, BDD, behavior-driven development. So if we specify what we want of a system in terms of, by giving it a testable, verifiable example, if I want, let's imagine I'm book shopping. So, go to the store, search for a book called Continuous Delivery, put the book in the shopping cart, go to the checkout, pay for the book. Now you own the book. That's a test. That's a verifiable outcome that I can measure. And so if we specified all that we want from the system in those kinds of terms, we could then use that as a way of verifying that that's also what we got. And it's a way of making us think in ways that are more precise. So I think there's a lot of the techniques that I would think of as engineering techniques that if we apply them to AI, they're even more important and even more valuable than they are for regular programming. So in some ways, there's this huge change that we're in the midst of. And in other ways, it's a huge change and the answer to it is the same as it was before.
No, that's amazing, right? I mean, some of these concepts like TDD, BDD, we have been talking about for the last 20 years, but it's amazing how they have become more critical in software engineering today. And also goes back to your point when you're saying at the beginning, right? These are the practices that some of the better engineers were already adopting, which means is they're getting better value from AI today than others.
I read a lovely article by a friend of mine, Brian Finster, today.
Oh yeah,
and he said that AI is like a high pass filter. It lets through the high performance, the high frequency, the good stuff, and it blocks the bad stuff. So if you're trying to do bad things, it's going to be like hitting a brick wall. You're not going to get through. But if you're already working well, you're going to fly. So I really like the analogy. It's really good.
That's amazing. Yeah, we have had Brian Finster a couple of times on the podcast as well. Amazing. So kind of I think this is an interesting perspective that you have also brought up, and we have also been thinking more about this. What is your, so one of the core things you're talking about with BDD is also clarity of intent, right?
Yes.
What are we trying to kind of do with this, and how do you actually, after that, how do you actually create testable workflows for it? So do you think this is sort of similar to the spec-driven development concept that has been going around lately?
I do. When I first read the stuff around spec-driven development, I thought they were talking about the same thing. I think there are some nuanced differences between what we're talking about. I think the flavour of what I'm trying to describe and what some people mean when they're talking about spec-driven development, there are some differences that I think are important, but maybe subtle if you're not dipped in the kind of work that I've been doing. And that is some of the spec-driven development folks seem to be saying or implying that you've got to come up with all the specifications up front. And I think that's a mistake. I think that software development as a practice, whether with or without AI, is profoundly an exploratory process. It's going back to what I was saying earlier about programming languages as tools that allow us to think about a problem and analyze a problem. I think we need to incrementally explore a problem so that we can see it, so that we can understand the details that we haven't thought of yet. So we're not going to get a specification right, in blank. We're going to have to specify something, interact with the system in some ways, learn from what we learn what we can from that, and then specifying something new. So ideas like modularity, cohesion, separation of concerns, and all that kind of stuff are still important. Testability, you mentioned the word, is deeply important because we want to be able to test the pieces that we're creating in isolation from each other and understand them. And we need models of how we're going to think about those. So this goes back to what I was saying earlier about design thinking. We need to think about the shapes that we're painting, even if it's the AI that's actually filling in the colors.
So going into kind of like, feedback loops and testability. So one of the things also happening today is with AI is generally good at also writing tests. But that also means it can possibly create a false sense of confidence in the code.
Yeah.
Like, how do you think about like, the evolution of testing, feedback loops, and like building that trust?
I think this is an area where we have to be really careful. And the problem here is if the AI is writing the code and the tests, what are we doing? What are we bringing to the party? How do we know that it's giving us what it is that we want? There has to be some way in which we specify what it is that we want of the systems that that we're working on. And traditionally, in traditional programming, we did that by deciding on how we were going to solve the problem. So we'd learn enough to understand the problem well enough, and then we'd come up with a solution that would solve that problem. And that's one way of solving it. I think there's a profound shift in terms of the way that AI programming is starting to work, where it's much less about the detail of the code than it used to be. And it's much less about the solution in some ways than it used to be. It's much more about specifying what we want to happen in sufficient detail so that we can verify that that's what we got. And that's why the thinking in terms of test-driven development and acceptance test-driven development using BDD is really important, it seems to me, because then we can say we'd like to achieve this outcome. We don't really mind too much what the solution looks like underneath, as long as it achieves the outcome and it continues to achieve the outcome. So verification becomes the bottleneck. So I was talking to I had a great pleasure. I'm going to name drop, if you'll forgive me.
Go for it.
I spoke to Gene Kim on my podcast, and he invited me to go pair programming with him. So we did, and it was an absolute joy. But he was telling me about working with Steve Yegg, he's written a book with on vibe coding. Yeah, and he says that Steve is producing 12,000 lines of code a day. So I don't know about you, but I can't read 12,000 lines of code a day. I certainly can't understand them well enough to really feel that I own those completely. So we've got to find another way of getting that kind of verification. And I think we get that through testing. I think we get that by specifying more accurately what we want. I think that the huge change that we're talking about is moving from defining a solution to more detailed definition of the problem that we're trying to solve, the specification of the what we want, rather than the solving the problem ourselves. And then we leave the solution more to the AI. I still, don't get me wrong, I still want to look at the code that it generates and think about that, but that's at a different level. I'm now kind of looking almost from an architectural point of view, is, does it look sane enough? It's a bit like, I mentioned early on, I'm an old school assembler programmer. I used to like writing systems in assembler, but your focus is like looking at something through a microscope when you're writing assembler. And the vast majority of my career since then, occasionally I've wanted to know what the assembler of the high level language that what was generated in terms of the machine code, but mostly not. Mostly I didn't care. I think code is going to go that way. So we're going to turn something else. We're going to be programming in terms of specifications, because that's the level at which we must interact with it if we're going to keep any sort of control. And we're going to care a bit less about the shapes. That's problematic in lots of different ways, and there's lots of things that's going to be difficult about that. But I think that's the way that it's almost inevitably going to go because of the economics of it. It's going to be generating more code than we can keep up with.
Absolutely. This is something actually I've been also thinking a lot about in writing. So one thing I would bring up, just to double click on this, is You started at the beginning of this podcast, you did mention English is a complex or lossy language, or in some ways like language which can be ambiguous. Like, how
Yes.
do you think about, like, moving into that world where we are specifying things in English which can have ambiguity, and then you're now saying that we are not even looking at the code, which is more structured and accurate?
So I think we've got to find another way, a more abstract way of being structured and accurate. And I think BDD and acceptance test driven development, which in this sense are synonyms for one another, really, is that way. So there's a wonderful book by Goiko Adzik called Specification by Example, and in it he describes an analysis approach where you come up with an idea of what it is that you want the system to do, and then you imagine a concrete example of the system doing that. And I did that informally when I talked about buying a book earlier on. I didn't just say about buying a book. I said buying a specific book. And I didn't mention how much the book costs. But in a test, if we're going to do this in a spec by example form, we'd say we're going to go to the store, we're going to buy this book, and it's going to cost this much, and I'm going to pay that much, and what happens in that scenario. So I'm being very precise about the details of the scenario that matter, but from the point of view of the behavior of the system, not in terms of the implementation detail of it underneath. And so now I can verify that scenario. I go to the store, I buy a book, and I pay the right amount for the book, and I get the book. And then I could imagine that's going to start me thinking about other scenarios that I might want to explore. So it gives me this tool that allows me to explore the problem. So now I can think, oh, well, what would happen if I went to the store and I searched for the right book, but I paid the wrong amount of money?
Right.
Would I still have the book? No. So there's a different scenario, and so on. And so there's all of these things that we can think of, as a tool, how we could use this as a tool. In BDD, we talk about building a domain-specific language to express the interactions with the system. I think this is the same. I think that the skill of programming is going to turn from using programming languages to building our own feature-specific programming language to express the specifications of what we want from the system. And those aren't going to just be imagining some user interacting with it. They're going to be, and I want a response in 20 milliseconds or whatever else it is. It's, and I want this I want the user not to lose any money when this bit crashes. It's going to be all of those sorts of things as well. So we're still going to have to think in technical terms. We're still going to have to decompose problems. It's just that the tools that we will use and the way that we think about this, I think, will change a little bit and mean that we can move more quickly. I've been thinking lately, I'm building a training course for my training website at the moment on architecture and design. And I've been thinking a little bit about what this means for what AI means for architecture. And one of the things that it means is that, let's imagine that we had a specification that described all of the behaviors of the system, and we wanted to try out different architectures. We could tell the AI, so make all these tests pass, but now try it as a monolith, now try it as a microservices architecture, or whatever else it was that we wanted. Now try it as an event-based system. We could do that and try out and do A/B testing against the architectures of the system that we wanted. It gives us lots of capabilities that haven't really been practically possible before.
Right. I think the cost of software building has been going down, which means is now you have the optionality to actually build out systems with that you're willing to just discard away as options. Absolutely.
And there's some of the stuff that traditionally old lags like me would have thought in terms of being defensive in terms of design, so that we have these tricks that we would use to avoid the mistakes that we'd made lots of times in the past. And some of those things are still important and some of them are not. One of the concerns that I think is real is that I don't know how people will build that kind of experience. Because I built it by writing lots and lots of code and getting it wrong lots of times. So how do you do that if you're not that close to the code? It's a difficult problem, but I can't see any way in which this stops being a technical discipline, because
Yes.
the real skill has always been and will always be the ability to think about and decompose problems.
Yeah, we also do our Hangar DX virtual sessions where we had Bill Larson recently, and we are talking about exactly the same thing, which is like, how do you
Yeah,
actually, bring in sort of like, how do you upskill your engineers? What kind of like things that they should still be learning? And I think a lot of this
yeah,
was still the software engineering fundamentals.
absolutely. That's certainly my belief. I think you kindly mentioned my book, Modern Software Engineering, before. In that, there are 10 foundational principles, and I don't think they change one jot. I don't think AI modifies them at all. But I think it probably makes most programming languages, most libraries, most tools, at some level, one day obsolete. They become less important
Right.
because even if they weren't there, the AI could write them for us in that long. So who cares?
So, given that we're talking about software quality, how do you think about AI slop?
I think it's an interesting problem. I was very peripherally involved in some academic research into the quality of software that AI presented. We wanted to look into how maintainable the code that AI wrote was, and so they did a controlled experiment. So they had a bunch of programmers that solved a problem, were asked to add a new feature to some very nasty Java code, and another group of programmers that were asked to do exactly the same, only with AI assistance. So one group without, one group with, and then there was a third group who blindly took one of the outputs and were asked to do some more changes on top of that. So how hard was it? What to me was the really surprising answer was didn't really make any difference. The AI didn't make it any better, and it didn't make it any worse.
Hmm.
So I think that the people that are scaremongers saying that AI can't code and it can't write systems are wrong. And I think that the people that are claiming that you get tens or hundreds of times productivity are wrong too. There were some improvements in productivity, but it wasn't really related to either of those things. It was more to do with the experience and the approach of the individual. So this engineering stuff that we were talking about, if you're doing the good engineering things, you're working incrementally with good tests and all of that kind of stuff, you'd end up doing a better job with or without AI. But for those people, the research said it was about 55% more improvement in productivity, which is not nothing. 55% is a big deal. It's just not 10 times.
I mean, I think 55% is also on the higher end, at least according to some of the research I've read from some of the large
Yeah.
companies.
So it's pretty good. It was interesting stuff. And it goes back to Brian's point of the high pass filter. It seems to me that this was also backed up by the Dora research into AI as well, which came to similar conclusions, which is that if you're already working well, AI is going to be a big win. It's going to help you move forward even faster. But if you're working poorly, you're just going to dig a deeper hole faster.
Dave, I know we are coming close to time. Maybe we can do sort of like a little bit more forward looking. If you have some thoughts on like maybe organizations who are struggling with adopting AI or sort of like, building better engineering practices with AI, do you have any thoughts on like, some of the maybe even low hanging fruits or some things that they should like focus on to get better?
I do. I think that fundamentally what we're talking about is how do you work in a complex adaptive system, and working with AI is a complex adaptive system. And so in those sorts of systems, what you need to do is essentially carry out lots of little experiments, learn from the experiment, and then adapt to what you find. And so you want to find ways that work that way. There's another way of thinking about this. There's a law in signal processing called Nyquist-Shannon, which is that if you want to digitize a signal, you need to sample it at a minimum of twice the frequency of the highest frequency thing that you want to sample, because otherwise you'll miss parts of the signal. That means that's just fundamentally true about information. It's not just about signal processing. That's just fundamentally true. So if we want to do a better job of understanding where we are in software development, we've got to sample more frequently. We've got to iterate more quickly. We've got to understand where we are more correctly, more frequently, so our samples are accurate, which means that we need these tests. We need continuous integration. We need these tests that can verify where we are, verify that after this change, the AI didn't go mad and change our accounting system into Space Invaders or something behind our backs. Because it could do, without that kind of control, without that verification that everything worked, that could happen. So we've got to find ways to organize our work into these smaller steps and verify very quickly after each step. That means getting good at the techniques of iterating fast, making small changes, continuous integration, test-driven development, all of those kinds of things, to my mind. And it's not just to my mind. That's what a lot of the AI, leading technical people in the AI community are saying too.
Right.
AI researchers from Anthropic and stuff are saying very, very similar things.
So basically, AI is changing everything, but still everything remains the same in software engineering, the basic principles.
Yeah. I think, maybe we've finally found some principles that are durable in the face of change. That would be a nice thing, wouldn't it?
Amazing. So Dave, thank you so much for your time. I know we are this is an amazing conversation, and there is so much more we can drill into. Maybe we can do another session at some time in the future. And thank you everyone for listening. If you're interested in developer experience or work in DevOps and platform teams, we also run virtual Zoom sessions off the record. Join us on DX.community, and we run these podcasts for you to listen async as well. Again, Dave, this was a pleasure talking to you. Thank you so much for your time.
It's my pleasure. Thank you. And bye-bye, everyone.